All right, so let's go into number 5 first. So hopefully you guys were able to identify that the final answer, you're looking for miles. So that means that after you do all your calculations, you should end up with a number with the unit of measurement miles. Okay. So here it tells you 26 miles to the gallon. Another way that we can interpret that is 26 miles per gallon. Yes, of course. So this is going to be 26 miles per gallon. And then it tells you that the car can hold 13.2 gallons. So what you're going to have to do is convert gallons into miles. So super simple. Your starting value is going to be 13.2 gallons. You're going to set up your fraction. Since you want to get rid of gallons, we're going to put 1 gallon on the bottom, and that's going to be equal to 26 miles. So this is going to be your conversion factor. And then for the math, super easy. Just need to multiply 13.2 and 26, and you'll get 343.2. That's it. Any questions about that one? Hopefully not too bad. It's just a one-step conversion. Just to let you guys know, I'm looking at the test right now on the other screen, but it's going to be harder than this one. This is not going to be, there's no one-step conversion problems. Yeah.
Is there any way to identify which one to start with?
Yeah, usually it's going to be the number that's like standing alone. Because if you take a look at 26, right, that's a conversion factor. It's 26 miles per gallon.
Yeah.
So that tells you it's a fraction. Usually you won't start with the fraction.
So it's like 13.2.
Yeah. Sometimes you will, but usually you won't. Good question. All right. Any other questions? All right, let's go over number 6. So for number 6, it's asking how many minutes are in 1.6 years. So this one, you should see that you're looking for minutes, and then the only number we have is 1.6 years, right? So we're going to write 1.6 years. And then I know there's no conversion factors here, but you guys can use, what you guys know to make the conversion. In 1 year, there's going to be 365 days. And if you want to get super technical and say 365.25 days, that's fine too. But 365 is good. And then 1 day is going to be 24 hours. And then 1 hour is obviously going to be 60 minutes. So you do all the math for that. You can ignore all the ones on the bottom because dividing by 1 is not going to change anything. So 1.6 times 365 times 24 times, I put minus. Sorry, guys. 1.6 times 365 times 24 times 60. That's going to give you a 4960. Okay. Yes.
The answer is 40,000.
Yeah, so that's what sig figs. I didn't talk about sig figs because in my experience, you don't really need to use them. If you put 840,000, that's totally fine. If you put this, that's totally fine as well. As long as you follow the rules that I talked about or that were written on the first workbook, you should be fine. Okay. So a lot of these numbers, you don't look for an exact value. As long as it's pretty much the same, you should be good. Okay. All right. Any questions about that? Pretty simple. Okay. So let's move on to a different one. So for this one, I wanted you guys to work a little bit with scientific notation because there is a question on the test where you'll have to be able to interpret them. So let's go down to number 12 right here. Okay, the one that has scientific notation. And again, if it's kind of hard to see, please pull it up on your Chromebook. That way you can zoom in and whatnot. But I'm going to give you guys about 3 minutes. See if you guys can try number 12 on your own. You can work with the person next to you, and then I'll go over the answer with you guys in about 3 minutes. All right. All right. So for this problem, our starting number is going to be the 1.5 times 10 to the 8 kilometers. So we're going to start off by writing 1.5 times 10 to the 8 kilometers. Okay. Now, the way that we calculate this is going to be, or the way that you calculate might change depending on whether your calculator is scientific notation. If it does, great. If not, you'll have to do some math tricks. So I'm going to assume yours doesn't do it. So I'm going to show you guys some math tricks that you guys can use to work with scientific notation a little bit better. But if you know how to input this into your calculator and your calculator does it for you, then Good for you. That's great. Okay. So we need to convert this into minutes. Okay, so here we have kilometers, and then the only conversion factor we have right here is meters, and we have seconds, right? So we're gonna have to first turn kilometers into meters in order to use this conversion factor. Okay, so if you guys remember, 1 kilometer is equal to 1,000 meters. So that's gonna be our first conversion factor. Okay, so that's gonna allow us to cancel out kilometers. We got meters, which is what we want because we can get rid of it using this conversion factor right here. So it tells us that 3 times 10 to the 8 meters per 1 second. Okay, and that allows us to cancel out the meters. Okay. I'll pause right there. Any questions on how I set that up? Everybody go with that? Okay. All right, and then lastly, we have to turn seconds into minutes. So we're gonna set up this conversion factor again. So 60 seconds in 1 minute. And that's how we can turn kilometers into minutes. And then all our units of measurement cancel out. We only have minutes. So we're ready to go. All right, so that's probably the easier part. I think the math portion itself is a little bit trickier. So again, if you can just punch this into your calculator, that's great. But if not, you're going to need some tricks to kind of get you through this. One option is obviously, moving the decimal 8 times. But at that point, it might get really confusing. If you miss a 0, it'll mess up your whole calculations. But scientific notation is actually not too bad to work with. Okay, I'm going to write out what we're doing down here just so you can follow along. Okay, but first thing we're going to do is we're going to be multiplying 1.5 times 10 to the 8 with 1,000. Okay, so 1.5 times 10 to the 8. Okay, and then we're going to multiply that by 1,000. Now, the way that I like to think about scientific notation, the first thing you want to do is just multiply the numbers that look normal. So we got 1.5 times 1,000, right? So if you punch that into your calculator, you'll get 1,500. Okay, and then you can just stick the ugly looking part at the end. So if we multiply these two numbers together, we get 1,500 times 10 to the power of 8. Okay. Everybody good with that so far? Okay. Next, what we want to do is we're going to take that number and we're going to divide it by 3 times 10 to the 8. So we're going to do 1,500 times 10 to the 8 divided by 3 times 10 to the 8. Okay, so again, we're going to start by doing the operation with the normal numbers. So we're going to take 1,500 and divide it by 3. So if we do 1,500 divided by 3, you'll get 500. Okay, so far so good? Okay, so after that, you got the scientific notation part. And for the scientific notation part, if it is a division sign, you just need to subtract them from one another. Okay, so if you look at the exponents, it's 8 and 8. So 8 minus 8 is 0. So you'll end up with 10 to the power of 0. If you guys remember from math, anything to the power of 0 is 1. So 500 times 1, which is 500. That's it. That's how you can get rid of the scientific notation. I'll pause right there. That's probably the most confusing spot. Any questions on that? Okay, so just keep in mind, if your operation right here is a division sign, you're going to minus the exponents. And then, obviously, if you're multiplying the two, you're going to add the exponents. Okay, so that's how you can work with scientific notation, even if you don't have a fancy calculator that does all that for you. Okay, just work with the regular numbers first, do the regular operation, and then for the exponents, just add or subtract depending on whether it's being multiplied or divided right there. Okay. All right, last step. We did this one right here. So we have 500, and then we just need to divide that by 60. And then that's going to give us a value of 8.3. And then that's going to be our answer in minutes. Okay. A lot of math, right? All right. Any questions on that? That's on the test. It won't be that hard. The scientific notation. It's pretty simple. I just wanted you guys to be comfortable working with it. Alrighty, anybody still need some time to copy this down? Okay, yeah. I'll leave that up there for a little bit. So while I have that up there, let me actually go through, or let me give you guys some of the topics that are gonna be on the exam. I'll type it up here so you guys can jot it down. I want to make sure that you guys are, focused with the way that you guys are studying. So, first of all, and I'll erase this in just a second. There are going to be, how many are there? 5 multiple choice questions. So 5 multiple choice. And then there are 3 short FRQs. Okay, and those are the ones that you have to show your work for. So for your calculation. So just to let you guys know, for the AP chemistry test, the multiple choice questions, you don't need to show any work. Some of the questions you might have to, do work in order to find the answer on your own. But we don't look at the multiple choice questions like the work that you did. All we care about is your final answer. Okay, so just a heads up about that. So there's no partial credit for the MCQs. Okay, however, for the FRQs, there is going to be partial credit. So showing calculations helps, because depending, if you, let's say you get the answer wrong at the end, but you had a lot of the steps correct, you will get partial credit for that. Okay. Okay, so that's going to be what's on your test. So let me go through the actual topics. For the MCQs, let's start with the MCQs. One of the topics I think you'll need to know is how to calculate mass percent. So we talked about that in the last lecture. So got total mass, and then what's the percentage of mass of something that's inside of that. Okay. I'm trying to be very careful so I don't give things away. Okay. Another one is going to be density calculations. So be comfortable doing dimensional analysis with density. Okay, the next thing is properties of alloys. Next one is going to be physical versus chemical changes. And then the last one is going to be understanding the difference between elements versus compounds. Okay, so those are the 5 MCQs. Okay, you'll need to know that. And just to let you guys know, I'll never do this again. This is the first and only time I'll tell you what's on the test by topic. After this one, it's going to be whatever we talked about in class. Okay. And for these, don't be so focused on definitions, like don't memorize the definitions word for word. What matters is that you understand the concept and then that you're able to apply it in different questions. So I highly recommend if you go on Google and just look up questions about these topics, AP Chem questions, you'll get a bunch. How many of you guys have set up your College Board class, AP Classroom? Okay, if you have not, I recommend doing that because there are practice problems on there and you could filter by topic. And that's a good way to get a lot of experience with these questions as well. Okay. Also, questions in the back of the digital textbook will help. There's questions on YouTube even. And then if you always want questions, you can let me know and I can send you some questions to work on. Okay. All right. For the FRQs, the first one is going to be density. The next one, oh, they're all density. Okay, so there are 3 densities. So dimensional analysis with densities. I will give you guys a heads up. The calculations might get a little bit complicated. So just make sure that you're comfortable working with dimensional analysis and converting the units together or with each other. And that's it. That's what your first test will look like. So I'm gonna leave that up there for a bit. But any questions? Yeah. This one. 15, yeah, thank you. Yeah, it's on Canvas already, but 15 points. Yeah.
Can we do any properties of alloys?
Oh, okay, yeah, let's do it. Thank you. Let's do that today then. So I'll pull that up in a sec. I think there's one at the end of the class workbook. We'll do that one together. That'll kind of give you a gauge for the difficulty.
Yeah,
okay.
I think I saw it somewhere for like.
Yeah. Yeah, what's up? Great question. I will put that up right now. So my College Board class code is that right there. JW396E. And again, throughout the entire year, on the AP Classroom, there's a lot of questions by topic that you can look up and work on. Okay. All right, any other questions? Yes. Okay, I will get that figured out during our break today, and I'll get that figured out. Yes, it's closed notes. So yeah, this class, all the tests are closed notes because AP test is closed notes, unfortunately. Okay, so let's do one alloy question and then we'll take our break and then we're actually going to start unit 2 today. All right. Okay, so I'm going to pull it up. If you guys want to go to the class workbook just so you have it on your screen, that's fine. But it's going to be this question right here. 1.10. I know it's kind of hard for you guys to see, so you might want it on your screen. But I'm gonna give you guys I'll give you guys 4 minutes to pull this up on your screen. It's in the class workbook, the thing that we looked at last time. It's at the very bottom. And this is about the difficulty you'll be looking at for the alloy question on your test. Okay, so I'll give you guys about 4 minutes to get into that. Try it out, talk with the person next to you. I know it's a lot of reading for this one, but we'll go over it in 4 minutes. Okay, so here we have 2 different alloys. We got bronze that's made out of copper and tin, and then we got steel, and those are made, or that one is made out of iron and carbon. Okay, so before we get started, let's just take a look at what the question is looking for, because that'll kind of help guide the way we think. So here it tells us there's 2 alloys, and then which of the following correctly describes the malleability of both alloys? And the key thing here is compared to their primary metals. Okay, so let's just think about, or let's talk about malleability first. So if you take a look above, we have a lot of info about alloys, right? But the key thing I want you guys to take a look at is point number 4 right here. Okay, the point of an alloy is to make the metal stronger, right? And if the metal is stronger, the malleability goes down. Okay, and the key point is that it's always going to be less malleable than the metals from which they are created. So if you take a look at bronze, what that means is bronze is less malleable than copper and it's less malleable than tin. We're not talking about the difference between copper and tin, right? We're talking about the alloy and then the primary metals. That also means steel is always going to be less malleable than iron and less malleable than carbon. Okay, and this is why it's important to read the question carefully, because we're comparing it not the primary metals with each other. We're looking at the primary metals and the alloy itself. So we're comparing bronze and copper, bronze and tin, okay, and steel and iron, and steel and carbon. We're not looking at the relationship between these 2. Does that make sense? Okay, so the answer's pretty easy then. We just kind of take a look at the options. This one is saying bronze malleability comparable to copper, steel's malleability is significantly lower than iron. Okay, so here we're not really, if you take a look at A, this might be an answer because bronze, it might be comparable to copper, I don't know. Okay, same thing here, but if you take a look at C, C is going to be incorrect because we know that the alloys are always going to be less malleable, right? And then if you go to D, D is the one that is spot on. It says bronze and steel are going to have malleability values lower than their primary metal. So D is going to be the correct answer. Okay? Yes. What it's made out of.
So it would be
Yeah, so for like this one, yeah, this one is comparing it with copper, so it's comparing bronze with copper and then steel with iron. Yeah.
So just when it says primary metals, it's not comparing with one of them.
Oh, either of them. Yeah, it might specify, but primary metals is just what it's made out of. Yeah, good question. All right. And the one on your exam is going to be kind of similar to this. Okay. Any questions? All right, so let's take our 5-minute break. If you need to run to the restroom, take a stretch break, you can. And then in 5 minutes, we'll get started with unit 2. So if you want to pull up the second class workbook for unit 2, you can do that as well.